Hello and welcome to part 2 of lesson number 3 in Unit 7 Exponential Functions in our grade 11 University College math class. So today in this lesson we introduced applications of exponential functions, which was sort of a gateway to talking about growth factors and the difference between growth and decay factors and growth and decay rates, which is sort of a fancy way of saying, what if your b value is going to be something other than a nice whole number like 2 for doubling or 3 for tripling or a half for a half-life? What if it's something different? So we talked about how to set this up. We saw that when we're creating a growth rate, we are adding a percentage to 1, but we have to express that percentage as a decimal. Same thing with decay, except that instead of adding it to 1, you're going to be subtracting it from 1, and in the same way you're going to be converting the percentage that you're subtracting into a decimal before you subtract it. And then you just do some calculations and off you go. So, as I said, not a lot of homework in this lesson. There's a few examples, so we're going to talk through them. We're going to do the first page, and the rest of it will be your homework. So, number 1 says, given the equation y equals 35 times 0.57 to the exponent x, what does this equation represent, growth or decay? So I've pre-filled this one out. It represents decay. And how do I know that? It's because I'm looking here at my b value, and my b value is going to be, my b value is less than 1. So that's how I'm able to tell that this is decay. Any number that shows up in the b spot that's smaller than 1 is going to be, and larger than 0 obviously, is going to be exponential decay as opposed to exponential growth. Now this is the tricky part, is what is the rate of growth or decay? So I want you to recall that this particular equation here, it started with y equals a b minus the percentage, whatever it happened to be. Ooh, it's a terrible percentage sign. There we go, to the exponent x over h. So that's where it started. We subtracted something from b. Oh, sorry, b. That should be a 1. I'm sorry. There we go. We subtracted something from 1 to get to 0.57. So what was that value going to be? The way to calculate that is to kind of just undo that operation. So if you consider that this, obviously you can see the answer, but if we do 1 minus 0.57, you will get 0.43. Now remember that 0.43 is a percentage currently being expressed as a decimal. So if we multiply this by 100, that's going to give you your 43%. Of course, you can also just move the decimal place 2 spots to the right. If that sort of makes sense to your brain, by all means do that. I think people find the decay ones to be the most challenging because you end up with values in your questions like 0.57, and you have to consider, how did I go from 1 to 0.57? And the way to figure it out, of course, is to subtract from 1 what the value was in the b spot, and then you can find out what was subtracted from it to get there. Hopefully that helps. I know it's a little bit confusing. The math is actually easier than trying to say it out loud, I believe, so keep your eye on the math. The next question is, what is the initial value? Well, that of course is our a. A value is just kind of hanging out front there. That's going to be 35. And we're going to evaluate for x equals 5. So what does that mean? Well, it means literally we're going to type in y equals 35 times 0.57 to the exponent 5. Bang that through the calculator, and we get 2.1 apparently. I'm not going to do this calculation. I trust that I copied it down correctly. So you should end up with 2.1 when you do this calculation. Let's go try a few more on our own here. So the next two are set up in a really similar way. So this might be a good time to use the first example that I gave you and maybe try to fill out these two full sections, all of 2 and all of 3, on your own. Maybe hit pause, give it a try, and come on back, and I'll just sort of whip through it as we go. Okay, you're back, which means you've tried these or you don't care to try them. Both are fine. So in our first example, or example number 2, we have y equals 225 times 1.23 to the exponent x. So does this equation represent growth or decay? Well, we have a b value here that is going to be larger than 1. It's 1.23, so this is going to be growth this time. And what is the growth or decay rate? So it wants to know 1 plus something gave us 1.23. Well, it's pretty obvious to see that that's 0.23, but remember, this has to be expressed as a percentage, not as a decimal. It has to be a percentage. The A value, of course, is the initial value sitting out there. It's going to be 225. And we are going to evaluate for x equals 2. So I'm going to type in that exact same equation, but I'm going to substitute 2 in there. So that'll be 225 times 1.23 to the exponent 2. And that's going to give me 340 decimal 4025. I guess we can write the whole thing down. 340.4025. So those are the answers that we have for example 2. Let's move right on to example number 3. So we have given equation 154 times 1.06 to the exponent x. Is this going to be growth or decay? Hopefully that it's obvious to you now, this value here is larger than 1, so this is going to be growth as well. And we have a growth rate. So again, we had originally this bracket was going to be 1 plus a percentage. What was that percentage going to be? To get us to 1.06, well, we're adding 0.06, which is going to be 6%. And the way that you can figure that out, if you want to, is you can take the piece that was added and multiply it by 100 to get back to the percentage itself. A value is hanging out front, so we can see it there. The A value right out front is going to be 154. And we are going to now go on to evaluate for x equals 7. So again, I'm just going to substitute in there. I'm typing in 154 times 1.06 to the exponent 7 in this case. And that's going to give me 231 decimal, it's 559, so let's just go 56. And there we go. So those are those two examples. Hopefully that makes sense just as a way of summarizing what we've been doing and how to figure it out. Now we're going to tackle just a few word problems to finish up the page here, and then you're off to the homework. So 4 says, a typical cup of coffee contains 100 milligrams of caffeine. Every hour, approximately 16% of the amount of caffeine in the body is metabolized and eliminated. Let C represent the amount of caffeine in the body in milligrams, and let T represent the number of hours since a typical cup of coffee was consumed. Write an equation where C is a function of T for a typical cup of coffee. Okay. First of all, let's look through the question for some clues here. So a typical cup of coffee contains 100 milligrams of caffeine. So that's going to be our A value. It tells you how much you start with. So every hour, approximately 16% of the amount of caffeine. Now metabolized or eliminated, that might not necessarily speak volumes, but we're going to be decreasing the amount of caffeine in the body. So this is going to be a case where our B value is 1 minus that percentage. So again, I'm just going to write down the bare bones of it here, where we would have Y equals A, B minus the, 1, done that twice today, 1 minus the percentage to the exponent X over T. So now we're going to start to build it. So it wants us to use the variable C to represent the amount of caffeine left in the body. So let's start with a C equals. Now the A value was 100 milligrams of caffeine. We have 1 minus the percentage. So again, let's just jump to it this time. So 16 over 100 will be 0.16, and to the exponent time. Now it hasn't told us exactly how much time has gone by yet, so we're just going to keep that x up there. But it did tell us that it happens every hour. So as long as we're counting our time in hours, this is going to be x, whoops, that's a highlighter, it's going to be x over 1, which is just going to be x, which is nice for us. Now again, I typically recommend doing that calculation. I always think that's sort of a nice way to go. So in this case, we would end up having C equals 100. So 1 minus 0.16 is 0.84 to the exponent x. Now again, I would mark both of these right on a test. You don't have to go ahead and do the math that's happening in the bracket, but it doesn't hurt either. Okay, so there's our equation. And the B part is how much caffeine is left in the body after 3 hours. So we're just going to put in and evaluate here. So that means we are going to put in the place of our x, we are going to pop in 3. So let's type that in now. So we have 100 times 0.84 to the exponent 3 hours, 3 over 1, so that's going to be 3, and that's going to be 59.27 milligrams. It's 2704, but you know, 2 decimal places is plenty. So again, that's our calculation there. And that's how we develop the equation and work the calculation. So suppose an individual cannot sleep unless she has less than 50 milligrams of caffeine in her blood. How many hours after drinking coffee must she wait until she's able to fall asleep? So again, after 3 hours, she's down to 59 from that original 100. They're suggesting a scenario here where she wants to have less than 50. So are there ways to figure out exactly when that's going to be? Yes. Are we going to be doing those here? We are not. That is a different topic. I think they cover it in advanced functions in grade 12. So we don't even need to tackle that in our grade 11 year, no matter which course you're in. So for us, we're just going to play guess and check. Now, after 3 hours, it seems reasonable that we should be trying 4 here to figure out if that's going to work. So we're going to type in C equals 100. That was 0.84. That was 3 hours. Let's go try 4 hours now and see what we get. That would be where we want to look. So 100 times 0.84 to the exponent 4 equals, yep, so we're at 49.787, so we'll say 79 milligrams. So we would say how many hours after drinking coffee? 4 hours should take care of it. It's not it exactly, but it's pretty close to 4 hours. Okay, so as usual, I run along with this video. We've only got 2 questions to go. So I'm gonna just stop the video here and maybe do a couple extras from the second page too. All right, so hang in for part 3.